Hello students, welcome back to Happy Learning. In today's session we are discussing factor theorem from class 9 chapter 2 polynomials. So let us start factor theorem. So factor theorem, first of all we have to know what is factor. So to clear this concept, let us write one example here. 14 divided by 7. Okay, when we are dividing 14 with 7, what will happen? We know 14, when we are dividing with 7, the quotient is 2, 7 2s are 14 and the remainder is 0. Okay, so in this case, when the remainder is 0 coming, or if the division is exactly divisible, then in that case we will say 7 is the factor of 14 and at the same time 2 is also the factor of 14. No, that means 14's factors are 2 and 7. Okay, so these two are the factors. More factors are there. 1 is also the factor. 1 is the factor of all the numbers and 14 is also the factor. Okay, in this case, in this particular division, which are the factors? 7 is the factor, and if we are dividing with 2, that time quotient it is coming 7, so we can say 7 is also the factor of 14. What is the reason? Because remainder is coming 0. Okay, so when exactly divisible numbers are occurring, that time the quotient and the divisor, both it is what? The factors. Okay, so this concept we know. Okay, so the same thing when we are applying in polynomials, what will happen? Let us look with the help of one example. Check x minus 1 is a factor of x square plus x minus 2. So this is the dividend and this is the divisor. So in this particular question we have to check this x minus 1, this polynomial is the factor of x square plus x minus 2. So we will do this particular question with the help of remainder theorem, because already we studied the remainder theorem. What is remainder theorem? When we are dividing this divisor with this dividend, so if in that case if we are getting the remainder, when we are applying the remainder theorem, of course we are getting the remainder. So that remainder, if it is 0, then we can decide it is factor or not factor. If with the help of remainder theorem, first we will find out what is the remainder. Then after getting the remainder, either it is 0 or not, that we have to look. If it is 0, then it is a factor. If it is not 0, then the particular polynomial is not the factor of x square plus x minus 2. Like that way we have to do. Okay, so here the p of x is p of x is equal to x square plus x minus 2 dividend. Now the divisor, it is x minus 1. Now what we studied in remainder theorem, just recall, whatever the divisor is there, take the 0 of its polynomial and that value we have to substitute in the question or in the dividend. Okay, then only we will get the value. Okay, that means that is the remainder. So what is the 0 of this polynomial? 0 of this polynomial, that is positive 1. So this value we have to substitute here. So p of 1 equal to 1 square plus 1 minus 2. That is equal to 1 square is 1 itself, we know, plus 1 minus 2 equal to 1 plus 1 2 minus 2, that means 0. That means when we substituted 1 in this polynomial, we got the value, we got the answer, and we know that answer is what? Remainder. So here the remainder is 0. That means these two are exactly divisible numbers. That means this divisor is what? The factor of this polynomial. Okay, so we can say therefore x minus 1 is a factor of x square plus x minus 2. That's all. Okay, so this is the way factor theorem we are applying in polynomials. Okay, I hope you understand. Now it's theory. Okay, so first of all something different is written in our textbook. So first itself, if we are reading that, or if you are going to understand that, little bit problem will occur. That why only what is the concept here we clear. Now after this, if we are reading that, then we will understand more better. Okay, so here is the statement for factor theorem. Let P of x be a polynomial of degree greater or equal to 1. That means whatever is our dividend, its power, the highest power, maybe it can come as 1 or greater than 1. Okay, so that is the first condition which way they given in the remainder theorem. And a be a real number, any real number. This a can stand for any real number, okay, such that P of a equal to 0. So on the basis of remainder theorem, P of a, it is what? 0. Okay, P of a, it is what in remainder theorem? That is remainder. So that P of a here, it is what? 0. That means in this particular statement, the remainder is coming what? 0. Then x minus a is a factor of P of x. If remainder, here they not, the word they not use, remainder is equal to 0, like that way word they not use. They are saying P of a equal to 0. And we know our learning is over. What is remainder theorem? P of a is the remainder, okay, and that remainder is 0 here, okay. So in that case, x minus a, that means the divisor is a factor. In that case, it is a factor of the dividend, that means P of x. Okay, so up to here we will check. So we have to consider a polynomial. Let the polynomial, it is what? P of x, because this is in general, no? So P of x is equal to, then divisor, we know dividend is equal to, divisor into quotient. Dividend is equal to divisor into quotient plus remainder. Okay, so divisor, it is x minus a into quotient q of x plus remainder, that is r of x. Okay, now here P of a equal to 0. P of a, it is what? Remainder. So remainder is 0. So this term completely 0. So P of x equal to x minus a into q of x. This term no need want to write, because that completely it is 0, no? Okay, so P of x is equal to, when the remainder is coming 0, the dividend is equal to the product of quotient, divisor and quotient. That what we got here. Okay, so actually this is the proof. This is the proof for factor theorem. Okay, so here this is in product. That means suppose here instead of P of x, to understanding only I am just writing, instead of P of x, if we are taking 14, and that is the product of 7 and 2, no? Remainder is 0, because these two numbers are exactly divisible with 14. Okay. So 7 and 2 are the factors. 7 is also a factor of 14. 2 is also a factor of 40. Okay, so for understanding only I return this to these numbers. Actually this is the proof for factor theorem. Okay, now the next part, conversely, that means this is the way we are not applying. In the application level, this is the way we are not applying. We are applying its reverse, that means conversely. What actually we are doing in problems, x minus a is a factor of P of x. Already we are saying the divisor is the factor of the given polynomial. In that case, P of a equal to 0 is coming. Okay, so already I did the questions, that means related to digits and polynomials. So in that method we are actually applying. Okay, so this is the statement for factor theorem, and this is the proof for factor theorem. Okay, so for factor theorem, always the remainder, if it is coming 0, that time the two numbers means in the place of divisor and in the place of quotient, both are what? Factors. If it is not coming 0, what not coming 0? Remainder, if it is not coming 0, then they are not the factors. That's all. So first question, determine which of the following polynomials has x plus 1 a factor. Okay, so in that several dividends are there. First question we taken, in this dividend, x plus 1 is a factor or not. In this polynomial, that one is a factor or not, that we have to check. So here we are going to apply the factor theorem. So for factor theorem, first we have to get remainder. Okay, we have to get remainder, no, first of all, then only we can check it is 0 or not. So how we will get the remainder? By using the remainder theorem we will get remainder theorem. That means remainder. So first of all we have to use here remainder theorem, then we will get a remainder. It is 0 or not, that we have to check. If it is 0, so x plus 1 is a factor. If it is not 0, so not factor. Like that way we are doing. Okay, so this is the application. So here solution we are starting. P of x. The question we are writing. Question it is x cube plus x square plus x plus 1. Okay. So this is the question. Now 0 of this polynomial x plus 1 is equal to 0, x is equal to negative 1. That value we have to substitute here. P of negative 1 is equal to negative 1's cube plus negative 1's square plus negative 1 plus 1. Okay. Now here the power it is odd, so negative 1 itself. Here the power it is even, so positive 1. Positive and negative, the ultimate sign is negative, plus 1. Negative 1 and positive 1 cancel. Negative 1 and positive 1 cancel. So here we got 0, and according to the remainder theorem, when we are applying the 0 of the polynomial, what value we are getting? We are getting the value of remainder. So in sense here we got the remainder as 0. If we are getting remainder as 0, then x plus 1, this is the factor of this polynomial. Okay, so we can write the conclusion. Therefore here the remainder is 0. In this particular question the remainder is 0. So therefore x plus 1 is a factor of x cube plus x square plus x plus 1. This is the answer for the first question. Now move on to the second one. Questions pattern it is same, only dividend is changing. Okay, x raised to 4 plus x cube plus x square plus x plus 1. In this we have to check that is a factor or not. So the same process. Solution we are starting. P of x is equal to x raised to 4 plus x cube plus x square plus x plus 1. Now 0 of this polynomial already we seen in the previous question, so that is negative 1. No? So that negative 1 we have to substitute. P of negative 1 is equal to negative 1 raised to 4 plus negative 1 raised to 3 plus negative 1 raised to 2 plus negative 1 and plus 1. Now powers we have to change. So here will come positive and here also will come positive. Why? Because the powers are even. Here it will come negative. So here will come positive 1, minus 1, plus 1, minus 1, because positive and negative is the ultimate sign. So plus 1. Now which will be cancel out? Positive 1 and negative 1 cancel out. Positive 1 and negative 1 cancel out. Then what is balanced? 1 is balanced. That means the remainder is 1. That means P of negative 1 is equal to 1. When we are getting 0 only, at that time only we can say x plus 1 is the factor. Otherwise we can't say. So here P of negative 1 is not equal to 0. So therefore x plus 1 is not the factor of the given polynomial. Polynomial I am writing like this way. Factor of P of x. Okay. Third question. X raised to 4 plus 3x cube plus 3x square plus x plus 1. Same divisor we have to check that is a factor or not. So we are starting the solution. Okay. P of x. Question we have to write x raised to 4 plus 3x raised to 3 plus 3x square plus x plus 1. And we know the 0 of the polynomial is common because the divisor is not changing. So negative 1. So when we are substituting negative 1 raised to 4 plus 3 into negative 1 raised to 3 plus 3 into negative 1 the whole square plus negative 1 and plus 1. Okay, is equal to positive 1 plus this is negative 1 itself because odd number of time. No? So 3 into negative 1, that is negative 3. So negative 3. Here this is positive 1. Positive 1 into 3, that is positive 3. Here it is negative 1 and plus 1. So positive 1 and negative 1 cancel. Negative 3 and positive 3 cancel. Here what is remaining? 1 is remaining and that is the remainder. That means P of negative 1 what equal to 1, which means P of negative 1 is not equal to 0. Therefore, we can say clearly x plus 1 is not the factor of this given polynomial. So, x plus 1 is not the factor of P of x. It is not the factor of P of x. Okay. So the third question over. Now move on to the fourth one. X cube minus x square minus 2 plus root 2 into x plus root 2. So this is the dividend. This is the question. X plus 1 is a factor. That's what we have to check. So solution P of x is equal to x cube minus x square minus 2 plus root into x, root 2 into x plus root 2. This is the polynomial. Now 0 of that polynomial, that is negative 1, that value we have to substitute P of negative 1. Okay, very carefully we have to substitute. Bracket is here. Okay, and where we are substituting negative 1, where x variables are coming, there only we are substituting. Okay, and here we have to remove the bracket also. So negative 1 the whole cube. Now in this step only substitution we are doing. Negative 1 the whole cube minus negative 1 the whole square minus 2 plus root 2 into negative 1, because where is x, there we have to substitute negative 1 plus root 2. Now carefully do the calculation. Here negative 1 itself will come because cube, no, here positive 1 will come inside the bracket. Positive 1, positive into negative, that is negative 1. Okay, now here is negative and on the other side of the bracket again negative. That means these two, it is what? Same. That means multiplication. Brackets this side and this side. That means this we can bring to this side. No, so negative into negative become what? Positive. Okay, so outside it is what? Positive 1. Here also negative, here also negative. So that means positive 1. And positive 1 when we are multiplying with these two, so the same number, no, 1 into 2, 2, 1 into root 2, root 2. So that we have to write. Okay, so here we have to write 2 plus root 2, then plus this root. Okay, so this is the calculation. That means the substitution. After that we simplified that. Again we will simplify. Negative 1 and negative 1, that is negative 2. This is plus 2. So these two will cancel. No? Then here what is balance? 2 times root 2 came. So 1x plus another x, 2 times x. So here 2 times root 2. So what is the answer? 2 times root 2. So here our remainder, when we substituted negative 1, we got 2 root 2, and which is not equal to 0. Clearly x plus 1 is not the factor. So P of negative 1 is not equal to 0. So therefore x plus 1 is not the factor of the given polynomial, factor of the polynomial P of x. Okay, so first set is over. Now move on to question number 2. Use the factor theorem to determine whether g of x is a factor of p of x in each of the following cases. So this is the first particular question. Okay, three questions, three subdivisions are the first question here given. This is the dividend and this is the divisor. Okay, so as usual way we have to do. Okay, so what is the 0 of this polynomial? That is negative 1. 0 of this polynomial, x plus 1 equal to 0. So therefore x is equal to negative 1. This value we have to substitute. So P of negative 1 is equal to 2 into negative 1 the whole cube plus instead of x we have to substitute negative 1 square minus 2 into negative 1 minus 1. Now calculation. Here negative 1 itself will come, so negative 2. This is positive 1 and this is positive 2 and this is negative 1. Negative 2 and positive 2 cancel out. Positive 1 and negative 1 also cancel out. So what is balance? 0 is there. Okay, so P of negative 1 is 0. That means remainder is 0. So P of negative 1 is 0. So therefore whether g of x is a factor of p of x. Yes, so we can write g of x, it is what? X plus 1. So x plus 1 is a factor of this polynomial. Polynomial p of x also we can write, or complete polynomial also we can write. 2x cube plus x square minus 2x minus 1. So this is the factor because we got the remainder as 0. Second question. P of x, x cube plus 3x square plus 3x plus 1 and g of x, that means the divisor is x plus 1. This is a factor or not, that we have to check. So what is the 0 of this polynomial? X plus 2, that is equal to 0. So therefore x is equal to negative 2. This value we have to substitute here. Okay, so P of negative 2 equal to negative 2 the whole cube plus 3 into negative 2 the whole square plus 3 into negative 2 plus 1. Negative 2's cube, it is 8. Now negative 3 time if it is coming, so negative 8. Okay, now here even is the power, even number of times, so positive ultimate sign is positive. 2 2s are 4, 4 3s are 12. Here 3 into negative 2, that is negative 6. Okay, then plus 1. Then here negative numbers are there and positive numbers are also there. So what is the shortcut? All the negatives you add together, all the positives you add together. 8 and 6 when we are adding, we will get negative 14. 12 and 1 when we are adding, we will get positive 13. So these two different signs, so we have to subtract, so we are getting negative 1. We are not getting 0, so that means x plus 2 is not the factor. So P of negative 2 is this, that means P of negative 2 is not equal to 0. Therefore x plus 2 is not the factor of this polynomial, is not the factor of this polynomial. Factor of x cube plus 3x square plus 3x plus 1. Okay, now next question. Third question. P of x is x cube minus 4x square plus x plus 6 and the divisor is x minus 3. So what is the 0 of this polynomial? That is positive 3. X minus 3 equal to 0. So therefore what is the value of x? Transpose that 3. So that is positive 3. So this value we have to substitute. So P of 3 equal to 3's cube minus 4 into 3's square plus 3 plus 6. Now 3's cube, it is 27. 3's square, it is 9. 9 into 4, that is 36 and the sign is negative sign. Plus 3 and plus 6. Okay, 3 plus 6, that is 9. So we will write that here, plus 9. 27 and 9 signs are positive, so we will add this 2, so we are getting 36. 36 minus 36, both will cancel out, so the answer is what? 0. That means when we substituted 3, we got 0, that means remainder is 0. So P of 3 equal to 0, so therefore x minus 3 is the factor of this polynomial. X cube minus 4x square plus x plus 6. So the second question also we completed. Third question, find the value of k if x minus 1 is a factor of p of x, okay, in each of the following cases. Here what is the question? So, let's observe this. Here in the question itself they are saying x minus 1 is a factor of the polynomial. Here we no need want to check it is factor or not, okay. They already saying in question itself it is saying the x minus 1 is a factor. Confirmly it is a factor, okay. Then we have to find out. Here the target is different. Here we have to no need want to find out this is a factor or not. Here we have to find out what is the value of k, okay, the unknown value, okay. So variable is here. For this variable's value we have to find out, okay. Now this is the important statement. This is the important statement. Already they are saying x minus 1 is a factor. So if x minus 1 is a factor, then definitely remainder will be 0, no? So with that we have to start, okay. So p of x is equal to this. This is the dividend, this is the divisor. So we have to take the 0 of the polynomial. X minus 1 is equal to 0, x is equal to positive 1. This value we have to substitute. So p of 1 is equal to 1 square, that is 1 itself, 1 plus k, okay. Up to here we know, because in all the previous question also we did like this way. From here onwards little change is there. That change because of this. Here they are saying this is the factor. So we have to substitute this as 0 because 1 is the 0 of this polynomial, okay. That means x minus 1 is the factor they said, no? So that means we will get definitely 0. So that in advance we are substituting, and now this is in the form of a simple equation. Then we can find out the missing value of this variable, okay. So let us. So 1 plus 1, that is 2, 2 plus k equal to 0. So therefore k equal to 0 minus 2. This positive 2 on the other side, that is negative 2. So what is the value of k? Therefore k equal to negative 2. So this is the way we have to find out the values for the variable if the divisor is already a factor, okay. Now move on to the next question. P of x is equal to 2x square plus kx plus root 2, okay. What is the 0 of this polynomial? That is positive 1. That value we are substituting. So p of 1 is equal to 2 into 1 square, that is 2 itself. Here k itself will come, and here it is root 2, because there is no variable. If it is the root 2 will come, okay. Now here we have to substitute 0 because already this polynomial is the factor. So we will get remainder as 0, no doubt in that. So in advance we are substituting that. Now it is a simple equation. Now we can find out the value for k. Transpose all these two digits to the other side. So k is equal to, this is positive 2, on the other side negative 2. This is also negative root 2. Now in both negatives it is common, so we can take negative outside. So 2 plus root. This is the value for k. P of x is equal to kx square minus root 2x plus 1. 0 of the polynomial, that is positive 1. So p of 1 is equal to k minus root 2 plus 1 equal to 0, because that is the factor. Now this is negative 2, on the other side it is positive, and this is negative 1. So therefore k's value is equal to root 2 minus 1, because root 2 it is in this side, left hand side it is negative, on the other side it is positive. This is here positive, on the other side it is negative. So what is the value of k in this polynomial? What is the value of k? That is root 2 minus 1. Fourth question, p of x is equal to kx square minus 3x plus k. 0 of the polynomial, positive 1. We are going to substitute. P of 1 is equal to k minus 3 plus k, which is equal to 0. K plus k 2 times, so 2k. 2k minus 3 is equal to 0. We have to find out the value for k. Okay, so 2k is equal to positive 3. So therefore k is equal to positive 3 by 2, because this 2 it is here in multiplication. So on the other side division. So what is the value of k? K is equal to 3 by 2. So this is the fourth question. Third questions, four subdivisions are there, and this is the last question in that. Okay, I hope you understand the solutions. Okay, thank you.